So question 51 from the homework, we're asked to find, what is the concentration of lead from lead to iodide, right? So lead to iodide is our weak electrolyte. It ionizes, giving us lead 2 plus and 2 iodine. And it's a common ion effect because we also have the strong electrolyte calcium iodide present. So we set up our ice table, right? Initial change and equilibrium. Initially, we have 0 lead, and we're going to get X amount of lead more. That's what we're looking for, the concentration of lead. What is our concentration of iodide in this solution? So we have calcium iodide, right? Calcium iodide is going to ionize. Yes. Yep, calcium iodide ionizes to give us calcium 2 plus and 2 iodines. So as a result, our concentration of iodide is going to be twice the concentration of calcium iodide, so 0.2 molar iodide. And yeah, we know, okay, sure, I'm going to get X amount of more from the lead iodide, but we know we can ignore that. And so at equilibrium, I'm going to have 0.2 molar iodide. So like I said, they give you all this extra information that you don't really need. 500 milliliters, 5 grams of potassium, of lead iodide. You don't need any of that information. Nothing you need is the calcium iodide and that concentration, and to know how calcium iodide ionizes. So now we can find our concentration, right? We know KSP equals the concentration of lead times the concentration of iodide squared. So KSP equals 1.4 times 10 to the minus 8. That equals X times my concentration of iodine squared. So 0.2. Right, you get 1 times 10 to the minus 8 equals X times 0.04. We're going to divide both sides by 0.04. And X should be right, 3.5 times 10 to the minus 7. What is X, right? X is my concentration of lead in solution. So 3.5 times 10 to the minus 7 molar lead, 2 plus. That's well below 5 grams of lead. So all that information they gave us about 5 grams of lead iodide and blah, 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 did not need to know that information. That's just extra information there. So yeah, just another common ionic question. The trick being, as we saw, right, within calcium iodide, we're going to have 2 iodides. So that concentration of calcium iodide is going to give us twice the concentration of iodine in our calculation.